Now this video is going to be on 3C force due to gravity. Now let's look at one. How would the mass and weight of an object on the moon compare to the mass and weight of the same object on Earth? So number one, I told you in class, we learned in this class, mass does not change. Mass does not change. Mass is the amount of matter in an object, right? What stuff you are made up of. And regardless of whether or not you're on Earth or on Jupiter, on Pluto or the moon or anywhere, you are made up of the same matter. You are you. You don't change. Weight, on the other hand, weight is a measure of the gravitational pull you feel towards an object, right? So right now we're close to Earth, so our weight is how close we are. Well, I wouldn't say. Let me start over. Is how hard Earth is pulling on us right now. Moon has less gravity, so you're gonna weigh less because the moon has less gravity. It's pulling on you less. You're gonna weigh less on the moon. So on Earth you weigh more. Earth weighs more. On Earth you weigh more. Let's get rid of that S. And on the moon you weigh less. Alright, so the answer would be B. Answer would be B. B. So number two, great. Number two. A person weighing 785 newtons on the surface of Earth would weigh 298 newtons on the surface of Mars. So what's the magnitude of the gravitational field strength on the surface of Mars? There are two ways to do this. The first way is I feel like it's a very obvious, or rather straightforward way. I wouldn't use obvious. It's straightforward. So on Earth, let's see, your force due to gravity on Earth, G Earth is 185 newtons. And on Mars, it's going to be 298 newtons. Now, we know that G on Earth, right, the gravitational field strength is 9.8 meters per second squared. But we want to find out what that is, right, on Mars. We want to find out what it is on Mars. And G Mars, G Earth. Well, if we know our mass doesn't change, again, mass is going to equal to the mass on Mars. Your mass doesn't change. So let's figure out what mass is first. Fg is going to, well, Fg is equal to mg. And so we substitute 785, and we get m 9.8. All right, 9.8, 9.8. So we're going to get somewhere around 70 probably. Somewhere around 70 is mass, 7 kg, somewhere around there. Again, if you use a calculator, you're not going to get, probably not going to get 70. So now we just figured out mass. We just figured out mass right here. All right, so, well, now we can use it over here. Again, it's almost. So now we just solve for g. Well, set up the equation. We know Fg is 298. We know our mass is 70. And we want to solve for g. And now we just solve for g now, which is going to be 303.72 newtons over kg. And that is the answer. The answer is B. There's another way you could have solved it without even calculating mass. Well, if we know that, let's say this too, FG Earth and FG. You know what? Sure, never mind. Okay. So let's call it F Earth. Okay. And F Mars. And this is equal to mass G Earth. It's equal to mass G Mars. Alright, so since we know that mass is the same, let's put it in terms of mass. Fe is equal to, no. F E to M G E F M is equal to M G M. Solve it in terms of M. Well, Fe is equal to Ge is equal to M. Fm is equal to Gm is equal to M. Well, since we know that mass is the same, we can set these two equal to each other. We can set Fe is equal to G Fm over Gm. We're just plugging everything in and solve for Gm. Let's do that. Let's do just that. So this is going to be Fe. Fe is 785 over Ge, which is 9.8. Fm is 298. And GM is something. So you just solve for GM and you should still get 3.72 nkg. Alright, that's what you should still get. But that requires you knowing the formulas and knowing how to manipulate it. The other way was pretty straightforward. Alright, number 3 is pretty simple. So if your mass of a spacecraft on the surface of Earth is 2 times 10 to the 4 kg, and the question is asking you, well, what is the mass of the spacecraft at a distance of 1 Earth radius above Earth's surface? Your mass never changes. Doesn't matter where you are. So the answer is going to be B. You still have the same mass. Still have the same mass. Number 4. Acceleration due to gravity on the moon is approximately what? Approximately what? Well, if you think about it, again, this is going to be your slope. You're going to go back to your motion graph slopes, right? You're going to use your knowledge of slopes. Your slope is change in y over change in x. And we know that Fg, and that's what your weight is. This is weight. This is weight. Is equal to m times g. Or m times a. Doesn't matter. And so, well, now if we divide m on both sides, well, we get g is equal to fg over m. Huh, that looks familiar. What's on your y-axis? Your weight. Weight's on your y-axis. What's on your x-axis? Your mass. Mass is on your x-axis. Look at this. Look at this. Look at this. Oh, man. Your slope is your acceleration due to gravity. So all you need to do is calculate the slope anywhere. So let's say slope. Let's say we're taking the point of y-axis is 24. On the x-axis, we're going to take 15. And so we're going to get, 1.6. 1.6 meters per second squared. All right. 5. What is the weight of a 2 kilogram object on the surface of Mars? So now we have, surface of Earth, my bad. 2.00 kg. Now G on Earth is, we know G on Earth is 9.8 meters per second squared. Then we know my force due to gravity, which is my weight. So go to 2.9, 2 times 9.8, 19.6 Newton, 19.6 newtons. Simple. 6. A 65 kilogram astronaut, 65 kg astronaut, weighs 638 newtons at the surface of Earth. What's the mass of the astronaut at the surface of the moon, where the acceleration due to gravity is 1.6 meters per second squared? It's still asking you about mass and weight. If you have a mass of 65 kilograms on Earth, your mass on the moon is most likely still 65 kilograms. Still 65 kilograms. That's the answer. That's the end of the video.